Okay, this is question 3 on the 2019 WJC additional maths paper. So this is an identity question. And I can see this an identity question because of this triple equal sign. That means that no matter what the value of x that we put in, this left-hand side will always give us this right-hand side. So if I want to prove that, what I need to do is take that left-hand side, rearrange it to get the right-hand side. So I'm not going to worry about the right-hand side at all. I'm just going to focus on the left. Because we've got 3 fractions, 1, 2, 3, with a denominator of 110, because that's the lowest common denominator of those 3. So let's have a look at the first one. So x over 2. If I want to make that have a denominator of 110, I need to multiply top and bottom by 55. Because that would give me 110 on the bottom. So I'd have 55 lots of the x over 55 lots of the 2 is 110. Then I take away. Okay, so now here I had a 5 on there. Now in order to get a 5 on the bottom to become 110, I need to multiply by 22. So that means I'd have to multiply the top by 22 as well. So I get 22 lots of x plus 3, which is this numerator, all over 110. Oops. Make the line straight. And then my last fraction, to make that have a denominator of 110, multiply top and bottom by 10. So plus 10 lots of x plus 5 over 110. Now, the best way to write this is to go straight away and rewrite it without doing anything to the numerator, but put it all over the same denominator. So it's automatically all over 110. So we have our 55x. And we can do this because if we have the same denominator, all we do is we add or subtract the numerators. So we have 55x minus 22, x plus 3, plus 10 lots of x plus 5. And the reason that I do that and put it over one fraction is because this negative often causes people problems when they separate fractions. It's far less likely that it's going to cause them problems if it's in the same fraction. People tend to remember the negative 22 multiplied by the 3, whereas otherwise, quite often in this one, they'll do negative 22 times x and then forget about the negative on the next one. So now it's time for me to sort out the top line. So we have 55x. Okay, expand that bracket. I get 22, or negative 22 times x is negative 22x. And negative 22 times 3 is negative 66. Then I have plus 10 times x is 10x. And 10 times 5 is 50, so plus 50. And that's all over 110. Now, if I've done this right, what should happen is that everything here on the top will add up to 43x minus 16. So let's have a look at what we got. Let's look at our x's. 55x minus 22x plus 10x. So 55, that's 65x. Take away 22 is going to be 43x. So that's good. That's what we want. So 43x. And then the constant, negative 66 plus 50 is negative 16 over 110. Okay, so the left-hand side, and we should really put the the identity symbol in rather than equals, because it's true for every single value of x now. And that is what we were trying to prove. So you could say as required, or you could be smug, super smug in Latin, and write QED. And that's how you do it.